Coulombs' law is a law stating that like charges repel and opposites attract, but they also show you the actual value of those two forces. So the force is actually proportional to the product of the charges and inversely proportional to the square of the distance between them. So you can see that if the charges were further apart, that the force would decrease quite a bit. There'd be a very small force between these two. But if you had a larger charge, then it would increase the force quite a bit as well. So these charges, this is the force on the first charge by the force of 2, and the force on the second charge by the first. They're equal. The magnitudes are equal. They're just in different directions. It's just equal and opposite forces affecting each other. So let's say the charge on the first one was 3 microcoulombs. Well, that is 3 times 10 to the negative 6 coulombs. And nanocoulombs is times 10 to the negative 9th. So you'd have 5 times 10 to the negative 9th. And then centimeters, you can actually write out 3 times 10 to the negative 2 meters. Now, there's this K, because I said proportional, right? So there's this K proportion. Depends on how easily the electrostatic field can be transported in the medium, and in the air it's a 9 times 10 to the 9th. We'll look at the units in a minute. So let's look at the force would be the K value, which would be 9. This is just the proportional constant here, times the first charge, which is 3 times 10 to the negative 6 coulombs, and the second charge, which is 5 times 10 to the negative 9th coulombs, and you divide everything by 3.2 times 10 to the negative 2 squared. Make sure you do square the radius. That's the most common error. Now what I like to do is get a feel of it both with my calculator and without. You can just plug it straight into your calculator as long as you remember to put these parentheses in. But you also should be able to do it without a calculator. 9 times 10 to the 9th. Notice I'm separating out the coefficients from the base 10s. I'm going to bring them all together. So I'm going to say 3 times 10 to the negative 6. This is all in the numerator. Since it's being multiplied, this is just like saying divided by 1. 5 times 10 to the negative 9th. As you can see this one here. 5 times 10 to the negative 9th. Then I'm going to divide by 3.2. I'm squaring that, but I'm also squaring the 10 to the negative 2. Careful on that. Then in your calculator, you can do these separately. What this advantage of doing these are, sometimes the numbers are so small or so large when dealing with numbers with base 10 that you end up having numbers that won't be calculated in your calculator unless you have to do it by hand. So if I multiply the 9 times 3 times the 5 divided by 3.2, I divided by 3.2 twice because I'm using a iPhone. There we go. But you can do it by 3.2 squared. Then notice when you multiply numbers with the same base, you add the exponents. So really it's 10 to the 9th minus 6 minus 9. And then here, when you have numbers that you're raising to a power, you multiply. So 10 to negative 2 times 2 is negative 4. 9 minus 9 is 0. So I have 13.18 times 10 to the negative 6 divided by 10 to the negative 4. And when I take numbers and I divide numbers with the same base, I subtract the exponents. And I get 10 to the negative 2. And 10 to the negative 2 means to move my decimal place to make it smaller. 1, 2. And so I have 0.1318 newtons. Not a very large force between the two. However, if I bring it just a little bit closer, it's going to be quite a bit larger force. So that is the force between two objects when one is charged with 3 microcoulombs, the other one is 5 nanocoulombs, and there's 3.2 centimeters apart. So that's actually quite a ways away. So now let's take a look and see what the units on the K value are. Well, we know that force is measured in newtons. We don't know the units for K. We know coulombs times coulombs, let's just say coulombs squared, and radius is in meters squared. So in order to make all of these units come out, I'll put these like in brackets because I usually do that with units. In order to make this turn out, we would need newtons divided by coulombs squared times meters squared. And you say, what? How do you know that? Well, let's take a look. You can do it two ways. I'm going to go ahead and plug it in. Here's my K. Here's my coulombs squared divided by meters squared. And you can see how it cancels. Coulomb squared cancel, meter squared cancels, and I get newtons equals newtons. So what I did was I inverted these two, and I made sure that there was a newton on the end. So one other way to do it is this is the unknown. So people are going to try to get this all by itself. So to do that, they're going to multiply by meters squared, coulombs squared, meters squared, coulombs squared. These cancel. You get meters squared divided by coulombs squared times newtons. And that is what the units for K are. You do not need a measure to memorize that, but it does help to kind of play around with the values. We'll play around with it more in class. So we had newtons meters squared per coulomb squared.